So the next diagram looks very complicated on first looking at it, but we're going to go through this more slowly. So if we take the top input, I don't want you to worry too much about this y+1 here, but if we just take the first box, we can see that on in the vertical direction, this is the different parameters that we have. So maybe the top row is heart rate, the next row is blood pressure, and so on. And across the horizontal axis, we have time. So yeah, towards the end here, this is the last time point that we have, which might not be the same as the last time point in the patient's stay. It's just the time that we're predicting. Along the temporal route here, we have these filters, so these blue filters, which are looking back across time. So for this time point here, this is looking at this time point, the 1, 2 time points before, and the 1, 4 times before that. So that is essentially processing the heart rate across time. And then we also have a green filter here, which might be doing a completely different parameter. So this could be the example for the blood glucose. And the advantage of having completely different, so the different colors represent the fact that we have different learned weights for each parameter. And the advantage of that is that each parameter being quite different might want very different processing to get the best out of it. So for example, a lab result might want to look further back in time than a heart rate would want to do that. So yeah, this just allows it to model the two independently from each other. On the pointwise side, so this is something that we haven't yet mentioned. So the pointwise idea is to take advantage of the inter-feature relationships. So the idea that if we look at more than one feature at a time, we can get more information than looking at them individually. So in this case, we have, we look at this entire box on the left, we just take absolutely everything that we know about the patient at a given time point. So we take their blood pressure, their heart rate, their glucose, everything, and then we condense that down to one representation. So if the model figures out that it's useful to look at the heart rate and the blood pressure together and to see how they vary with each other, that is a way that it can do that. Whereas on the temporal side, because it's just processing one parameter at a time, it doesn't get the opportunity to mix data from different types of parameter. So the model is designed to take advantage of both approaches and extract both types of feature in the process. So this is just one, if this is one iteration of our TPC model, so I say TPC because it's temporal pointwise convolution, we end up doing this 9 times. So we do this processing many, many times over. And then this is just to say that we also add another branch. So we have some diagnoses coming in here, and we have a diagnosis encoder, which is just a 1-layer neural network here, just to reduce the size or the number of neurons to represent the same amount of data. And we just put this in, so we add this onto the output of our TPC model. And then we then make the final prediction. So we do another pointwise operator here. So again, taking everything that we know at a set point in time, which might be what the patient's diagnoses are, what the age of the patient is, gender, and all of the time series after they've been processed. And then we get a final prediction.